Hello everyone. Concurrency control in databases. Session 7 of module 5 database management system. The content is developed for learning management system under Department of Collegiate and Technical Education. In this session, we will discuss about multi-version concurrency control techniques. Under this, we will discuss about multi-version techniques based on type-of ordering, multi-version two-phase locking using certified locks, and then we will discuss about validation or optimistic concurrency control techniques, and then granularity of data items and multiple granularity locking. Under this, we will discuss about granularity level considerations for locking, multiple granularity level locking, and then test multiple choice questions. First, we will discuss about multi-version concurrency control techniques. These protocols for concurrency control keep the old values of a data item when the item is updated. These protocols for concurrency control keep the old values of a data item when the item is updated. These are known as multi-version concurrency control because several versions or values of an item are maintained. When a transaction requests access to an item, an appropriate version is chosen to maintain the serializability of the currently executing schedule, if possible. The idea is that some read operations that would be rejected in other techniques can still be accepted by reading an older versions of the item to maintain serializability. When a transaction writes an item, it writes a new version and the old versions of the item, and old versions of the items are retained. When transaction writes an item, it writes a new version and the old version of the item are retained. A drawback of the multi-version concurrency control is that it requires more storage. More storage is needed to maintain multiple versions of the database items. Multi-version techniques based on timestamp ordering. In this method, several versions x1, x2 up to xk of each data item x are maintained. For each version, the value of version xi and the following two timestamps are kept. What are the two timestamps? First one is read underscore ts of xi. The read timestamp of xi is the largest of all the timestamps of transactions that have successfully read version xi. What do you mean by read underscore ts of xi? The read timestamp of xi is the largest of all the timestamps of transactions that have successfully read version xi. Write underscore ts of xi. The write timestamp of xi is the timestamp of the transaction that wrote the value of version xi. What do you mean by write underscore ts of xi? The write timestamp of xi is the timestamp of the transaction that wrote the value of version xi. Whenever a transaction T is allowed to execute a write underscore item x, write underscore item x operation. A new version xk plus 1 of item x is created with both write underscore ts of xk plus 1 and the read underscore ts of xk plus 1 set to ts of t. Correspondingly, when a transaction t is allowed to read the value of version xi, the value of read underscore ts of xi is set to the larger of the current read underscore ts of xi and ts of t. To ensure the serializability, the following rules are used. To ensure serializability, the following rules are used. If a transaction E uses a write underscore item of x operation and version I of x is the highest write underscore ts of xi of all versions of x, that is also less than or equal to ts of t. If a transaction t uses a write underscore item of x operation and version I of x as the highest write underscore ts of xi of all versions of x, that is also less than or equal to ts of t, and read underscore ts of xi greater than ts of t, then abort and roll back transaction t. Otherwise, create a new version xj of x with read underscore ts of xj equal to write underscore ts of xj equal to ts of t. And the next rule is, if transaction t uses a read underscore item of x operation, find the version I of x that has the highest write underscore ts of xi of all versions of x, that is also less than or equal to ts of t. Then return the value of xi to transaction t and set the value of read underscore ts of xi to the larger of ts of t and the current read underscore ts of xi. In the first rule, there is a write underscore item of x operation. In the second rule, read underscore item of x operation. Next, multi-version two-phase locking using certify locks. In this multiple mode locking scheme, there are three locking modes for an item. There are three locking modes for an item. They are read, write and certify. Hence, the state of lock of x for an item x can be one of read lock, write lock, certify lock or unlock. We can describe the relationship between read and write locks in the standard scheme by means of the lock compatibility table. We can describe the relationship between read and write locks in the standard schema by means of the lock compatibility table. The compatibility tables are a compatibility table for read, write locking schema. Read, write, read, write. Read and read, yes. Read and write, no. write and read, no. Write and write, no. On the second table, log compatibility tables for read, write and certify logging schema. First table only read and write. The second table, three modes: read, write and certify modes. Read and read, yes. Read and write, yes. Read and certify, no. Write and read, yes. Write and write, no. Write and certify, no. Certify and read, no. Certify and write, no. Certify and certify, no. Here in these tables, an entry of S means that if a transaction T holds the type of log specified, in the column header, the type of log specified in the column header, an item X, and if transaction T requests the type of log specified in the row header. Column header indicates type of log specified in the column header. Okay, this one, transaction T holds the read log. Row header indicates transaction T requests the log. Transaction T requests the type of log specified in the row. This one, hold, column indicates log holds, row indicates request the type of log. Request the type of log specified in the row header on the same data item X. Then transaction T can obtain the log because the logging modes are compatible. Means yes, means the logging modes are compatible. Here in this case, the S indicates the logging modes are compatible. In these tables, the entry no indicates the logs are not compatible. The entry no indicates the logs are not compatible. So T dash in transaction, any transaction T dash must wait until transaction T releases the log. The idea behind optimistic or multi-version two-phase locking protocol is to allow other transactions T dash to read an item X, while a single transaction T holds the write log on X. This is accomplished by allowing two versions for each item X. One version must always have been written by some committed transaction. The second version X dash is created when a transaction T requests a write log on the item. What is the idea behind multi-version two-phase locking protocol? Is to allow other transaction T dash to read an item X, while a single transaction T holds the write log on X. This is by allowing two versions for each item X. One version must always have been written by some committed transaction. The second version X dash is created when a transaction T acquires a write log on the item. Next we will discuss about validation or optimistic concurrency control technique. In optimistic concurrency control techniques, it's also known as validation or certification techniques. In this case, no checking is done while the transaction is executing. In validation or optimistic concurrency control techniques, no checking is done while the transaction is executing. In this scheme, updates in transaction are not applied directly. Updates in transaction are not applied directly to the database items until the transaction reaches its end. During transaction execution, all updates are applied to local copies of the data items that are kept for the transaction. At the end of transaction execution, a validation phase checks any of the transaction updates violate serializability. There are three phases for this concurrency control protocol. They are read phase, validation phase, and write phase. What do you mean by read phase, validation phase, and write phase? Read phase means a transaction can read values of committed data items from the database. In the read phase, a transaction can read values of committed data items from the database. However, updates are applied only to local copies or versions of the data items kept in the transaction workspace. What do you mean by validation phase? Checking is performed to ensure that serializability will not be violated if the transaction updates are applied to the database. In validation phase, checking is performed to ensure that serializability will not be violated if the transaction updates are applied to the database. And the third space is write space. In write space, if the validation space is successful, the transaction updates are applied to the database. Otherwise, the updates are discarded and the transaction is restarted. The idea behind optimistic concurrency control is to do all the checks at once. Hence, transaction execution proceeds with a minimum of overhead until the validation phase is reached. The techniques is called optimistic because they assume that little interference will occur and hence that there is no need to do checking during transaction execution. The validation space for transaction Ti checks that for each such transaction Tj that is either committed or is in its validation space, one of the following conditions holds. The first condition is transaction Tj completes its write space before Ti starts its read space. Second condition is Ti starts its write space after Tj completes its write space, and the read underscore set of Ti has no item in common with the write underscore set of Tj. And the third condition is both the read underscore set and write underscore set of Ti have no items in common with the write underscore set of Tj, and Tj completes its read space before Ti completes its read space. These are the four conditions of the validation space. Next we will discussing about granularity of data items and multiple granularity locking. All concurrency control techniques assume that the database is formed a number of named data items. A database item could be one of the following. A database item could be one of the following: a database record, a field value of database record, a disk block, a whole file, the whole database. The granularity can affect the performance of concurrency control and recovery. The granularity can affect the performance of concurrency control and recovery. Next, granularity level considerations for locking. Granularity level considerations for locking. The size of data items is often called the data item granularity. The size of data items is called the data item granularity. File granularity refers to small item sizes. File granularity refers to small item sizes, whereas coarse granularity refers to large item sizes. The larger the data item size, the lower the degree of concurrency permitted. The larger the data item size, the lower the degree of concurrency permitted. Next, we will discuss about multiple granularity level locking. What do you mean by multiple granularity level locking? Since the best granularity size depends on the given transaction, best granularity level depends on the granularity size depends on the given transaction. It seems appropriate that a database system could support multiple levels of granularity. Database should support multiple levels of granularity, where the granularity level can be different for various mixes of transactions. Right? The granularity level can be different for various mixes of transactions. This figure shows simple granularity hierarchy with a database containing two files. Database containing two files, F1, F2, each file containing several disk pages, right? Several disk pages, and each disk page containing several records. Right? This is the simple granularity hierarchy. Right? Here a database containing two files, F1, F2, each file containing several disk pages, right? And each page containing several records. This can be used to illustrate a multiple granularity level of two-phase locking protocol. This can be used to illustrate a multiple granularity level two-phase locking protocol, where a lock can be represented at any level. Lock can be represented at any level. Lock can be represented at database level, or file level, or disk page level, or record level. To make multiple granularity level locking practical, additional types of locks called intention locks are needed. To make multiple granularity level locking practical, additional types of locks called intention locks are needed. The idea behind intention lock is for a transaction to indicate along the path from the root to the desired node. Okay, here the idea behind intention lock is for a transaction to indicate along the path from the root to the desired node. What type of lock? Whether it can be shared lock or exclusive. Shared means read, exclusive lock for write. It will require from one of the node's descendants. There are three types of intention locks. Intention shared IS. Intention shared IS indicates that one or more shared locks will be requested. Intention shared indicates that one or more shared locks will be requested on some descendant nodes. Second type of intention locks is intention exclusive IX. First one is intention share IS, second one is intention exclusive, which indicates that one or more exclusive locks will be requested on some descendant nodes. And the next type of lock is shared intention exclusive SIX. SIX indicates that the current node is locked in shared mode, but that one or more exclusive locks will be requested on some descendant nodes. The compatibility table of the three intention locks and the shared and exclusive locks is shown in figure. This is the compatibility table of three intention locks. What is IS here? Intention shared. IX means intention exclusive. S means shared. SIX means shared, intensive, exclusive. X means exclusive. This is the compatibility table. Here the entry X indicates the modes are compatible. Entry no indicates are not compatible. The modes are not compatible. Now multiple granularity locking MGL protocol consists of the following rules. What is the rules of the multiple granularity locking? The lock compatibility based on this figure, the lock compatibility must be adhered to. It must be compatible. The root of the tree must be locked first in any mode. The root of the tree must be locked first in any mode. Any mode means there are three modes, right? These are three: read, write, or intention shared, intention exclusive, shared intention exclusive. The root of the tree must be locked first in any mode. Third rule is a node N can be locked by a transaction T in S or IS. S means only shared. IS means intention shared mode only. If the parent node N is already locked by transaction T in either intention shared or intention exclusive mode. The fourth rule is a node N can be locked by transaction T in X exclusive, IX intention exclusive, or SIX shared intention exclusive mode only if the parent of node N is already locked by transaction T in either intention exclusive or shared intention exclusive mode. And the fifth rule of the multiple granularity locking is a transaction T can lock a node only if it has not unlocked any node. A transaction T can lock a node only if it has not unlocked any node. Means to enforce the two-phase locking protocol. And the sixth rule of the multiple granularity locking is a transaction T can unlock a node. A transaction T can unlock a node N only if none of the children of node n are currently locked by T. The multiple granularity level protocol is especially suited when processing a mix of transactions that include short transactions that assess only a few items, means records or fields, and long transactions that assess entire bytes. In this environment, less transaction blocking and less locking overhead are incurred. Less transaction blocking and less locking overhead are incurred by such a protocol when compared to a single level granularity locking approach. Okay, in this environment means multiple granularity locking, less transaction blocking and less locking overhead are incurred by such a protocol when compared to a single level granularity locking approach. Then next, test multiple choice questions. First question is, the multiple granularity locking protocol uses multiple lock modes to ensure A. Sequence, B. Serializability, C. Deadlocks, D. Locking. Answer is B. Serializability. Second question is, a way of guarding against deadlock prevention is to A. Order data items, B. Order the execution, C. Order access, D. Order cascading. Answer is A. Order data items. Third question is, a write operation in multiversion timestamp ordering may result into the answer A. Abortion of transaction, B. Termination of transaction, C. Rollback of transaction, D. Waiting of transaction. Answer is C. Rollback of transaction. Fourth question is, snapshot isolation is a scheme of options are multiversion concurrency control, multiversion two-phase locking, multiversion timestamp ordering, multiversion one-phase locking. Answer is A. Multiversion concurrency control. And fifth question is, multiversion two-phase locking requires transactions to be declared as A. Read only, B. Update, C. Write only, D. Both A and B. Answer is D. Both A and B. And the sixth question is, the most common concurrency control schemes include locking protocols and A. Timestamp ordering scheme, B. Validation techniques, C. Multiversion scheme, D. All of the above. Answer is D. All of the above. Question number 1 B, question number 2 A, 3 C, 4 A, 5 D, 6 D. References. Thank you.